right, in this lesson, we're going to be evaluating algebraic expressions. I can apply my knowledge to simplifying numeric expressions, order of operations, so that I can evaluate algebraic expressions. I'll know I've got it when I score an 85% or better for this lesson assignment. All right, before we dive into evaluating algebraic expressions, we need to just do a review about what is an algebraic expression. Remember, algebraic expressions are made up of algebraic terms, and they can also have numeric expressions or numeric terms. Algebraic terms include variables, and they can have other operations like multiplication, division, and exponents within the term. So we have this example right here. It's an algebraic expression that reads x plus 7 times y minus 5. And remember that a couple of things to review when we're looking at these. The x is really 1x, but the 1 is dropped because it's not necessary. When you multiply by 1 to any number, you just get that number back. So they drop it to keep it in a simpler form, but we can always stick it in whenever we need it to help us get through some problems. So it's x plus, remember this is 7 times y right here. There's no multiplication symbol indicated because that's proper algebra notation. They just leave it out and you have to remember to translate it as 7 times y, that operation is in there, even though there's no symbol for it when we're in the algebraic term of it. And then minus 5, that's another term. So the algebraic terms in this expression, there are 3 terms in this expression. And again, we can find them easily if we just go through that process where we would highlight those plus and minus signs, and they're right there. And now you can clearly see those 3 terms. The first term is x or 1x. So we'll just put that. And that's an algebraic term because algebraic terms would have variables attached to them. So it's x or 1x if you want to see that number that's being multiplied to x. The second term is plus 7y. Remember, when we're in this algebraic piece, we're going to circle that plus or minus symbol to the left of the term because that plus or minus symbol belongs to that term, and that's going to be important later when we do more lessons in this unit, that you know that that's a plus 7y. So we'll just write it down here since it's plus, it's positive. We'll just write it as 7y. And then finally, our third term is numeric. It's a numeric term and it's minus 5. So since it's a numeric term, it's considered a constant. So I'm going to stick it down here as minus 5. When they have that minus in front, you want to indicate that it's a minus when you're identifying it. And it's a constant, and this is, or we say it's a numeric term because it's just a number. Okay, so it's a constant or a numeric term. All right, now that we've identified the algebraic terms and the numeric terms or the constants in that expression, let's break it down even further. So when you look at the algebraic terms, they have coefficients on them. So you can identify the coefficients, the number being multiplied. Remember, that's what that means. And we have our first term, the 1x, the coefficient is 1. And the variable is x when we break that term apart. When we break this one apart, the coefficient is 7, and we're multiplying that by y, so that's the variable. So we just have all these parts that make our algebraic expression, and identifying and knowing what they are, remember these vocabulary words and what they mean is going to be very important as we get further into this unit. Okay, the next term we want to just review, we've seen this one before, it applied in our numeric expressions. It also applies in our algebraic expressions, is the term evaluate. When you're asked to evaluate an algebraic expression, there's a couple things that happen. The first thing that you do is you substitute. So when you evaluate an algebraic expression, the first step is to substitute a number that you're given in for that variable that's in the problem. And once you've substituted, it becomes just like what we've reviewed, order of operations. It becomes a numeric expression, and you just simply simplify the expression or do the math. And the key is that you follow order of operations, that you funnel your steps in neat rows. Okay, so remember when we simplify an expression, we're decreasing the number of terms in that expression. And to do that, we follow order of operations and we perform those operations, which whittles our numbers down to a single simple answer. And this should not be new. We've done this. You've done it before with geometry formulas. And so when you're looking at this expression over here, it's algebraic because it has the letters in it. And it's 2 times the length plus 2 times the width. That geometry formula is the perimeter formula for rectangles. And so here's their formula. And so they say, hey, the length is 4 and the width is 10. So when they tell you what the numbers are, you simply plug those numbers into your expression. You replace the variables, you substitute what they tell you to use for L and what they tell you to use for W, which is 10, and you substitute them in for those letters that were there in our original formula. Once they're substituted in, you want to identify the terms in that numeric expression. And the easiest way to do that is to look for those plus and minus signs that separate them, separate those terms, and then you simply follow those order of operations. And it's been laid out for you here with those lines, so I want you to funnel that down by filling in the missing values for the blanks, and then turn the video back on when you're done. It is a good idea to have your checklist handy to keep you performing these in the right order. GEMDAS, remember that to put the MDDM in, so you go in the right order, and then ASSA, so you're performing in the right order. Stop the video, fill in the blanks, turn it back on to see if you got it. Okay, so I just want to point out something I didn't say earlier. When you plug in a number for multiplication, so it's 2 times L plus 2 times W. When you plug a number in place for that multiplication piece, the 4, 2 times 4, you have to put a symbol between the numbers to indicate you're now multiplying. So you would not want to just simply go 2 times 4 like that, like it's written here. And plus 2 times 10, whoops, that looks like a 4. It's supposed to be a plus sign. Plus 2 times 10 and write it like this. Because then you think the numbers are 24 and 210, but that is not correct. Remember, this is translated as 2 times the length plus 2 times the width. So you have to put a symbol in between. The symbol I like to use is simply drop that number inside parentheses. We did talk about that in a previous lesson. And when you drop them inside the parentheses, it still reads 2 times 4 plus 2 times 10. You can use the dot in between. And we are avoiding using the X because it started off as algebraic. So we try to avoid the X in between because that looks like the letter X and it gets confusing. So the parentheses or the dots are the most popular way. I highly recommend the grouping symbol around it to separate the 2 and the 4 to indicate we're multiplying. So you should have gotten 2 times 4. You do that multiplication. Clean it up, you get 8. Now you know you're adding 8 plus 2 times 10. Clean it up, you get 20. 8 plus 20 is 28. Okay, in this example, we have, I want you to, again, just plug the number in. Notice I've set it up for multiplication by using those parentheses to separate the number you're going to plug in for X from the 4. And that way we don't think it's 42. We know it's 4 times 2 when we put those parentheses between them. And then you're going to funnel it and turn it back on to see how you did. This is a short one. Hopefully you remembered that maybe putting the checklist here would be a good idea. Whenever you're doing the funneling, you should have it maybe somewhere handy so that you are walking through. And we look first for grouping symbols, and you might say, ha, we have grouping symbols right here. So we look inside them, and it's just a number. So that grouping symbol, there's no math to do inside. It's just here to separate. It's now no longer, oh, I got to do an operation. It just separates the 4 and the 2. So that's not really a grouping symbol the way we're used to using it here. It's used as a separator. So we go down the list. There's no exponent, so I'm going to check it off. We do have multiplication. That's next in our list. So this term requires multiplication. That's what these parentheses are telling you. They're multiplication symbols at this point. So we go 4 times 2 is 8. And then you go through your list. There's no division. We did the multiplication. And there's no subtraction or addition, but we do have subtraction. So we're going to do that one subtraction and get our 5. So in this next problem, it reads 5 times m squared plus 3 times m, for m equals 2.8. So we're given a decimal. We've covered decimals earlier in the year, and we also just covered some fraction problems and mixed number problems. So you're expected to know how to apply your knowledge from how to add, subtract, multiply, divide, and do exponents with those kinds of numbers here. So you can't forget that math we learned previously. And then the goal here is to make sure we're funneling properly as well. We are going to allow you to use a calculator in this unit, but caution with the calculator, it doesn't mean you just get to punch it all in and go from here to here. No, you're not going to get credit if you just punch it all in and you make the calculator follow the order of operations based on what the calculator knows. We need to know you understand the order of operations. So you need to funnel the steps in this way to say, hey, I know I'm supposed to do this computation first. I'll use the calculator. And then I'll do my next computation and I can use the calculator if I choose to, that kind of thing. So the first step before you do anything else, your first step is to substitute and do no math, just like we've been doing all along. So we're going to take this 2.8 and we're just going to substitute it in wherever there's an m, and there's 2 spots. So the first step, you do no computing, just like we've been doing in the previous examples. You just plug in the 2.8 wherever there's an m, and it's in 2 spots. And everything else just comes down around it. 5 times m, so it's 5 times 2.8 squared plus 3 times 2.8. Now you can use your calculator to do what you need to do following those order of operations. So we look over here, you should set up your little checklist, get your calculator handy, and we're going to look for grouping symbols. And you're going to say, hey, I see them. I see grouping symbols. So we're going to look at the grouping symbol and we're going to look inside it. There's no operation to perform inside this grouping symbol. So I'm like, okay, it's just there to hold the multiplication together. So I go, okay, what's next? Next after grouping symbols are those exponents. Oh, we do have an exponent. So it's right here. It's 2.8 squared. 5 times whatever we get when we square 2.8. So this is where you're going to go to that calculator and you're going to square 2.8. So pause the video and get your answer to 2.8 squared and then turn it back on to see what you got. So when you punch that into your calculator, you should have done either 2.8 and use your squared button, or you should have done 2.8 times 2.8. And you should have gotten 7.84. Then we go to this next term. Remember this term right here, that plus sign is right here that separates our 2 terms. Forgot to highlight that. Would have been a good idea. And we get 3 times 2.8. So I want you to pause the video and put that into your calculator, 3 times 2.8, and write your answer on the line below. You should have gotten 8.4. So now that our 2 terms that had operations with them are almost cleaned up, we're ready to do that next step. It's right here. This one comes next. Okay, so we did our exponents, and now there's multiplication that needs to be done. So we need to do the multiplication. And once we get that multiplication done, that term is finished and getting ready to subtract. So pause the video, and I want you to do 5 times 7.84, and then turn the video back on to see if you got it. You should have gotten 39.2 for that term. And then this term is done. So we're just going to bring it down so we can see what are the 2 numbers they wanted us to add together. Remember, they wanted us to add 5 times m squared to 3m. So we were doing this product plus this product. We've got those products all cleaned up, and now we get to add. You can use your calculator and write your answer on the line when you have it. And you should have gotten 47.6 as your final answer. So just remember, when we're saying you can use the calculator, it is there to help you speed yourself along and to have accuracy, to be more accurate. You still have to show us at each step what you're doing with that calculator. You can't punch the whole thing in and just go from the start to finish, because this is all about making sure you're following these order of operations yourself. And the calculator should help alleviate some of the time constraints and help you with that accuracy. But again, you should be able to do these without the calculator as well, because you are supposed to have mastery over the operations of those decimals. So it should still be in your wheelhouse with or without a calculator. But we are going to give you a little reprieve and let you use that calculator. Okay, so we're looking at this next example. I want you to pause the video. I want you to make sure you've identified your terms. You will probably want to put your little GEMDAS note down there so you're following the order of operations. And you can have your calculator handy to compute these as well. But you need to fill in the blanks with the proper numbers to show that funneling process. So it's been developed for you by putting these blanks here. You need to know what you're doing to get those accomplished. Pause the video, turn it back on when you're done to see if you got it. All right, so you should have plugged that 2.8 in here and the 2.67 here. And then your terms that you need to clean up before you can add, you need to figure out what these two numbers are. So we do the math on this one, and when we divide 7 by 2.8, you should have gotten 2.5. And when you multiplied 4 times 2.67, you should have gotten 10.68. And then when you added those two numbers together, you should have gotten 13.18. So that is that problem. So if you got it, awesome. If you didn't, stop, pause, try it again, fix, before you move on to the next example. All right, so we have this next example. It's 4x cubed minus 8x for x equals 3. And then your order of operations, you'll want to just write that over here in the workspace to make sure you're following them for each term that you clean up. And then turn the video back on when you're done. So we're trying to put this all together. You hopefully have had enough exposure and examples that you can do this problem successfully. Turn it back on when you're done. Good luck. So you should have plugged in 3 for the x in this term, and then plugged in 3 for the other x in this term. And when you plugged the 3's in, I used parentheses because it is a multiplication and we're replacing the variable in that algebraic term with the number. So we can't just put it as 4, 3 and 8, 3, because it isn't 443. It's 4 times 3 cubed. So we've got to put a symbol in between. And I like the parentheses. Some people might go like this, and some people might go like the 8 times 3 with the dot. Or the parentheses. I like the parentheses, so you'll see me do that quite a bit. And then we cube the 3 first because we're following the order of ops. And when I look at this term, it has two operations within it. It's got 4 times and it's got 3 cubed. Well, we can't multiply 4 to 3 because it's not 3, it's 3 to the 3rd power. So we got to do the, and again, the parentheses are there to show multiplication. There's no operation inside that. So we just kind of look for our next steps, which would be that exponent. So we do that first, and we get 3 to the 3rd power is 27. Hopefully you didn't write 9, because remember, exponents is repeated multiplication. So if you wrote 9, you need to fix that up, and you need to study your exponents some more. So we get 4 times 27 when we're done with that term, just that multiplication, or that exponent step. Then we do minus 8 times 3. Well, 8 times 3 is 24. This term only has one operation to it, and we just perform that operation and we're good. All right, so then we look at this next row and we say, hey, we still have this to clean up. It's multiplication. So we just do that multiplication, and then we minus the 24 term from it. We get 108 minus 24 is 84. So hopefully that went well. Fix it if it didn't, and if it did, good job, and we're going to keep on going. All right, so we have this algebraic expression. It's got 3 terms to it, and it's 8 times c divided by 6 minus c plus 8 for c equals 9. So you're going to pause the video. In your first row, you're going to simply substitute 9 in for that variable c, and you're not going to compute anything, just substitute. And then after you got that substitution, identify your terms. Be a good idea to highlight the pluses and minuses, and then clean up each term in between those that need it. And then when you're done, your final step would be to subtract, then add. So pause the video and work this through, and then turn the video back on to see how you did. All right, so just looking at this, you can see I highlighted the plus and minuses in the problem, and I could see that this had operations within it, so I was going to need to funnel this one down. And then this one was set. It's already in its simplest form, and so is this one. So I just need to keep bringing those down until this is a single number. I need to simplify this term out. So when I read this, it's 8 times 9 divided by 6. 8 times 9 divided by 6. I got multiplication and division. And it's hard to see which one goes left to right because they're sitting right on top of each other. But remember, when you have this division sign, it says you need a number divided by 6. To divide, you need to know what this single number is. Well, we don't have a single number. We got to make it. So 8 times 9 comes first, and we get 72. Now we know what to divide 6 into. So we got to clean up that multiplication first. And then once we get that multiplication cleaned, we divide next on that. So when you have those fractions with stuff happening in the top, you got to clean up the numerator, anything that's in the denominator. And once you got it down to a number over a number, you can divide. So we get 72 divided by 6 minus 9 plus 8. And these just came down. They were already ready to go, but we weren't ready to subtract because we don't have a number here yet. We've got to make this a single number so we know what to take 9 away from. So we go 72 divided by 6 is 12. And then now we're ready. Okay, we bring the 9 and the plus 8 down, the minus 9, the plus 8, and now we decide. So we're done with all of these blocks above, and we're left with just addition and subtraction. So I look at my options. Well, it's left to right, so it's addition first. No, it's subtraction. Get rid of that. So we go to subtraction first, and we get that 3. And then you add plus 8, and you get your 11. All right, so the next example. All right, so you're going to work this one out. I'm just trying to get my GEMDAS image in here. You should be reviewing those order of ops as you're working through these, using that as your guide. And you're going to plug in 0.4 and 0.5, and I recommend the calculator, but you're going to need to funnel this down. So neat rows, cleaning up each term, one operation at a time. Pause the video, turn it back on when you're done, and then you'll check your steps. So when you substituted in 0.4, that's 4/10. So we did 50 times 4/10 minus 12.2 times 5/10 plus 9.5. You need to have some kind of symbol here indicating your multiplication, a dot or these parentheses. So if you didn't put your multiplication symbol in and you wrote 50.04, 50 with a 0.4, that's not correct because that's 504/10. So make sure that multiplication symbol's in. Hopefully you got that figured out at this point. So when we multiply 50 times 0.4, we're taking 4/10 of it. We're taking 40% of 50, which you get 20. That makes sense. We're not taking all of 50, we're taking a piece of it. We're multiplying by a number that's smaller than 1, and that makes our 50 shrink when we multiply by that, taking 40%. Then we multiply the 12.2 times 0.5. Remember, 0.5 is 50%. We just took 50% of 12.2. So that 6.1 should make total sense there. We shrunk it. We took half of it. And then we add that 9.5. There was nothing to do to the 9.5. We have to just hold it until we get ready to add it. Now we just go left to right. So we added 20 and 6.1, and we got 26.1. And then we added 9.5 to that, and we got our 35.6. And this is your final example to try, and you've got 8 to the t power minus 9 times the quantity t plus 15 for t equals 3. So you're going to substitute 3 in wherever there's a t, and then you're going to funnel your steps, and then you're going to check to make sure you funneled properly. Use a calculator on this one as well, just for accuracy and speed. But make sure you're showing every row. So when you turn the video back on, if you're missing a row, it means you're doing too many steps on the calculator and not showing me that you understand what the calculator is doing to follow those order of operations. So one operation at a time on the calculator. All right, so you should have put in the 3 up here as an exponent, 8 to the third power minus 9 times 3 plus 15. And then when you follow the order of operations, you look at this first term right here, and it is 8 cubed. You take care of that exponent, it's 512. Then you got to go inside these grouping symbols. There's an operation to do, so you add, and you get 18. And now you're going to clean up in the next row. 512 just comes down. 9 times 18 is 162. And now you have 512 minus 162 is 350. So we did our exponents. There was no grouping symbols in our first term, so we did the exponents. We go to the second term, we did those grouping symbols. And then we were ready. Second term still needed some work, so we did that multiplication, and we were done. All right, you have an assignment following this. Hopefully it goes well. Keep your notes handy. Good luck.